Hello students, today we shall discuss memory allocation, which comes under memory management function of operating system. In memory management, today we shall discuss contiguous memory allocation. Contiguous memory allocation means continuously memory is allocated to processes in the main memory. Contiguous memory allocation is basically a method in which a single contiguous section of memory is allocated to a process or file needing it. As the process needs memory, it is allocated to it in the main memory. In this memory allocation, all the available memory space remains together in one place, which implies that the freely available memory partition are not spread over here and there across the whole memory space. In contiguous memory allocation, which is a memory management technique, whenever there is a request by the user process for the memory, then a single section of the contiguous memory block is given to the process according to its requirement. So here you can see the memory is divided into two parts. The first part of the memory is given to the operating system and the second part is given to the user processes. As the processes arrive, the memory is allocated to the processes. Here you can see that this part of the memory is given to process P1, this part of the memory is given to process P2. So continuously memory is allocated for user processes. The memory can be divided either in the fixed size partition or in the variable sized partition in order to allocate contiguous space to user processes. So this contiguous memory allocation can be done in two methods. First method is fixed size partition and second is the variable size partition. We shall see the first type of partition, contiguous allocation with fixed partitioning. In this method, this technique is also known as static partitioning. Static means fixed. So this technique is also known as static partitioning. In this scheme, the system divides the memory into fixed size partition. The whole main memory, which is allocated for the user process, is divided into partitions. And the size of the partitions is fixed. The partitions may or may not be of the same size. The size of each partition may contain exactly one process. The size of each partition is fixed as indicated by the name of the technique and it cannot be changed. There is a problem that this technique will limit the degree of multiprogramming because the number of partitions will basically decide the number of processes. So how many number of partitions, that many number of processes. So if the number of partitions is less number of processes will be included in the main memory, thereby decreasing the degree of multiprogramming. Whenever any process terminates, then the partition becomes available for another process. So there is a problem that this technique will limit the degree of multiprogramming because the number of partition will basically decide the number of processes. To allocate memory to processes in partitions, the operating system creates a table to store the information regarding the partitions in the memory. This table is known as partition description table. So here you can see the PDT, that is partition description table. The main memory will be divided into partitions having fixed size, and when they are allocated to a process, an entry to the partition table will be done. There are 4 fields in the partition table. First is the partition ID. Every partition is given a unique ID, and the partition has a starting memory address, what is the size of that partition, and whether it is allocated or not will be shown in the allocation status. The long-term scheduler performs job scheduling and decides which process is to be brought into the memory. It then finds out the size of the process to be loaded and requests the memory manager to allocate a partition in the memory. After getting a memory, the scheduler places the process in the allocated partition. Next, it enters the partition ID in the PCB of the process, and then PCB is linked to the chain of the ready queue. We already know this process of allocating process to the memory and then to the CPU. Memory manager marks the status of the partition as allocated. Initially, the status of all memory partition is free. With the use of PDT, that is partition description table, a list of available partitions is obtained and partitions are allocated to the process based on their memory requirements. Space at the end of the partition that is unused by the process is wasted. Wasted space within a partition is called internal fragmentation. This contiguous memory allocation with fixed partition has the problem of internal fragmentation. One method for reducing internal fragmentation is to use partitions of different sizes. Next, we will see the advantages of fixed size partition. This scheme is simple and is easy to implement. It supports multiprogramming as multiple processes can be stored inside the main memory. This management is easy for the operating system. This partition also has some disadvantages. The first disadvantage is internal fragmentation, which we have discussed previously. You can see over here that the memory is divided into 4 partitions. The first partition, that is of 8 MB, has been allocated to process P4. The size of process P4 is 6 MB. So 2 MB processes memory is wasted. Next partition is of 4 MB and process P1 is of 3 MB. So 1 MB of memory is wasted over here. Similarly, process P3 has been allocated for this partition of size 4 MB. Here also 1 MB is wasted. This block which you can see in red is the wasted memory, and that is known as the internal fragmentation. If in a case size of the process is more than that of the maximum size partition, then that process cannot be loaded into the memory. So now here you can see that this memory is wasted. This is the disadvantage of fixed size partitioning. Second is limitation on the size of process. If in a case size of the process is more than the size of sized partition, then the process cannot be loaded into the memory. Next disadvantage is external fragmentation. External fragmentation is the result of internal fragmentation. So here also you can see that in this partition this gray part is wasted. So now together if we put this memory but still, and we can allocate it to the next process, but since it is distributed, this total memory cannot be allocated to process 7. This concept is known as external fragmentation. Total unused space by various partition cannot be used in order to load the processes, even though there is the availability of space, but it is not in the contiguous manner. So this wasted space, if it was contiguous, we could have given it or allocated it to process 7. So this is all about contiguous allocation with fixed partition. Next we are going to see contiguous allocation with variable partitions. This scheme is also known as dynamic partition. Dynamic means keeps on changing. As in the previous case, the size of the partition was fixed, but in this case the size of the partition can be. This scheme came into existence to overcome the drawback, that is internal fragmentation, that is caused by static partitioning. The size of the partition is not declared initially. Whenever a partition of size equal to the size of the process is created and then allocated to the process, thus the size of each partition is equal to the size of the process. So here you can see this is our main memory. For first part is given to the operating system. Process P1 arrives, so it requires 3 MB. 3 MB of memory is allocated, so this becomes the first partition. The remaining processes arrive. Process P2 arrives and the next partition, which is of 5 MB, is given to process P2. Similarly, process 3 arrives, which requires 8 MB of memory, so the third partition is allocated to process P3. So in this case you can see that this partitions, the size has been changed. To overcome the disadvantage of fixed partition technique, a technique called MVT multiprogramming, that is multiprogramming with variable number of tasks, is used. In this technique, the amount of memory allocated is exactly the amount of memory a process requires. Now we shall see the advantages of variable size partition. First is it has no internal fragmentation. As in this partition scheme, space in the main memory is allocated strictly according to the requirement of the process. Internal fragmentation. Also, there will be no unused space left in the partition. Next advantage is degree of multiprogramming is dynamic. As there is no internal fragmentation in this partition scheme, due to which there is no unused space in the memory. Thus, more processes can be loaded into the memory at the same time. As in case of the fixed size partition, then how many number of partitions, only that number of processes can be bought in the memory. But in this case, since the size of the partition keeps on changing, the degree of multiprogramming can also be increased. No limitation on the size of process. In this partition scheme, as the partition is allocated to the process dynamically, thus the size of the process cannot be restricted, because the partition size is decided according to the process size. It has some disadvantages. External fragmentation. This fragmentation disadvantage is in fixed size partition as well as variable size partition. The main disadvantage of variable size partition is it is difficult to implement. The implementation of this partition scheme is difficult as compared to the fixed partitioning scheme, as it involves the allocation of memory at runtime rather than during the system configuration. As we know that operating system keeps a track of all the partitions, but here allocation and deallocation are done very frequently and partition size will be changed at each time. So it will be very difficult for the operating system to manage everything. Thank you.